Hi. In this video we're just going to quickly run through some post-estimation commands for regression in Stata. Mostly we're going to understand how Stata predicts, so we're going to understand where y hat comes from, and then we're going to look at the residuals, so we can look at the estimated residuals of the regression, and we're going to do that as well. So to start with, I'm going to use the example that has GDP, unemployment rate, and the CPI in it. I have it named state example data. It should be Stata example data, but I must have misspelled it. So I'm just going to go in, and the first thing I'm going to do is just load the data. And if we look at it, I have a time string, real GDP, unemployment rate, CPI. I converted it into a day, obviously, and then I have the quarter and the year. Next, I just want to have a time variable that says 1, 2, 3, 4, so a different unique time variable that's counting upwards for each year quarter. So 1959 1 should be 1, 1959 2 should be 2, 1959 3 should be 3, 59 4 would be 4, 1961 would be 5, 62 would be 6, so forth. So to do that, I'm going to drop my original time and then just create another time variable. So I'm going to use the egen command, and we're going to group by year quarter, and I'm putting year first to say that the earlier the year always gets precedent instead of quarter. If you did it the other way, all the ones would get, it would be sorted by quarter and then year, where we needed to sort it by year quarter. So just going to go ahead and run these two as well. And when I open it up, this is what I get. So I see a time variable that all it's just doing is increasing by 1. So this is telling me each unique quarter, and the higher the value, the later the date, or the later the quarterly values for GDP. Next, I'm going to go through, and if we just do a quick graph of GDP, so we'll just do a two-way very quickly, a line graph of GDP and time. This is what I get. And so this is our values of GDP increasing over time by quarter. If we look at this, it looks to be very a little bit concave. So we need to take away the growth on that. And to do that, we're just going to take the natural log. So anything that grows exponentially, if we take the log, it should convert it to a more linear value. So to do that, go back to my do file, and I'm going to generate ly equal to the log, or the natural log of GDP, and then we'll just throw a two-way line of ln GDP, or ln ly, and then time in there, so we can look to see what that looks like. We do that, and I get something that looks like this, which is, tends to look a little bit more linear than actual GDP values. So the next thing that we want to do is I want to regress and just see, so going back to the graph that I had, we notice that GDP tends to grow over time. So I just want to see what is the growth rate over time. As time increases, how much is the natural log of GDP expected to grow? So I'm just going to regress GDP on time. So to do that, I just use my reg command, reg ly and time, and I run that. I get my graph back, and this is what we see. So again, it looks, the natural log of GDP tends to increase by about 0.007 or 0.008 every quarter, and I'm fitting the data fairly well. In fact, I'm fitting about 99% of the variance of y with just a time lag for GDP. The next thing that we might want to do is we want to see, well, what does that time trend look like? So if we were to just take that time trend, what do the predicted values of GDP look like? So to do that, we're going to use the predict command. So after a regression, I can use predict, and then I call it whatever I want to, I name the variable. So predict is going to show me y hat, or it's going to say, so for time period 1, it's going to plug in 8.0947 plus 0.0076 for time period 1, and that will be ly hat for time period 1. For time period 2, it would be 8.0947 plus 0.0076 times 2, because time equals 2 in that case, and that would be ly hat for time period 2. And then for time period 3, this would be multiplied by 3, and then you add on the constant, so forth. So what does that look like? So if I use the predict command, it's going to generate a new variable called y hat with the predicted values of ly from this regression. Next, I'm just going to fit these into a graph. So I'm going to have a line graph of actual y, so ly, the predicted values of ly, and then I'm going to graph that over time. And if I do that, this is what I get. So again, the blue line here is going to be actual values of the natural log of GDP as it grows through time. And since I have a time trend and it's growing, it's a line, obviously we have a straight line shooting up with a constant slope of 0.0076 and an intercept of whatever it was, 8.06. And as you can see, we tend to fit the data fairly well. There are times where GDP is below the predicted values. There's time periods where it's above the predicted values, just based on this time trend. Okay, so this is the fitted values, which is what we called y hat. If we go back into our data, we can see here's what y hat is, and this is the actual log of GDP. So we're graphing these two things over time, and we're fitting fairly close to the data. Not exact, but fairly close. The next thing that we may want to know is, well, what is the error term? And if you remember, the error term, or the residual of a regression, is going to be actual value of y, which is ly in this case, minus y hat, which is the predicted value of y. So if we go this minus this is going to give us the estimated residual. So to do that, I'm going to go back into my do file, and I'm generating the resid. You can call this whatever you want. You can call it EU, error term, whatever you want to call it. I'm just calling it resid, so I know it's the residual of my regression. And then it's going to be equal to ly minus y hat, so the actual values of y minus the predicted values of y from our regression. And then I'm just going to graph how the residuals look over time. Go ahead and do that. And here's our graph. So this is, again, on the x-axis is time, or quarter. So it starts in quarter 1, ends in quarter 225 or so. And then we have the residual. So if this is negative, it means that the predicted value is larger than the actual value. If the residual is positive, it means that the actual value of the natural log of GDP was higher than predicted. And what we see is kind of this thing just bouncing around. Obviously, there are time periods where we're above and time periods below. So we're taking the time trend out of the difference. So if we go back to that first graph, this thing is growing. So imagine that we kink the line down. So we take this and we make it horizontal, or this red bar, and we make it horizontal, and we're dragging real GDP along with it, and then we're taking the difference. So this is going to be somewhat what we call maybe detrended GDP, where we're taking the time trend out of GDP. And that's what that looks like. So this is everything of GDP that isn't explained by a time trend. So this might be some sort of cyclical measure of GDP, where these would be expansions, where GDP is above prediction, and then we'd have recessions where GDP is below prediction.